Hi, it's Ms. Koltanova again, and we're going to do another one of the Similarity Transformations activities from Khan Academy, but the advanced ones. So hopefully you've watched the videos for the regular ones, or at least you're very comfortable being able to do those problem sets for the regular ones that are not advanced. And now we can go into the advanced ones that actually ask you to do it formally. Perform the transformations in a formal mode, meaning you're describing the exact transformation that you're doing. You're not letting the computer figure it out for you. Okay? So let's see. We're trying to figure out if these two rhombuses are similar. So the original one is going to be the blue figure, and we're going to try to make it map on top of the pink figure. So let's see what we can do here. All right. I'm drawn to point C. Point C is the third one listed when they name the polygon, so that should match up with G. All right, so C matches up with G over here. All right, I'm going to start first by doing a translation so that C matches up to G. And then I can do a rotation and a dilation or whatever else I need to do to get them to fall on top of each other. Okay, starting off. All right, now if C needs to move on to G, I need to move to the left. I need to go from 5 all the way to -8. So I need to move to the left a -13 boxes. Okay, and then I need to move down from 2 all the way to -3, so I'm moving down 5. Okay, great. Now the next thing that I need to do is I need to get them to face the same direction. So I want to make sure that this point B, which is over here, should match on top of F, which would allow me to do a quick counterclockwise, regular clockwise rotation. Let me make sure those should match up. B and F. Okay, good. All right. So I want to spin this figure so it spins, 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 and is facing to the right, right and left instead of straight up and down like this. All right, so I'm rotating. I need to make a center of rotation. So my center is going to be this point G that I want to remain fixed. I don't want this point to move since I just did all that work to get the 2 points to fall on top of each other. So my center of rotation is going to be at -8, -3. I need to type that in. -8, -3. Right, now by how much? Now if I'm spinning this to the right, that's like the hands of a clock. So it's going to be a negative rotation. And right now it's pointing due north, and I want it to point due east. So I'm going to say that probably is going to be a 90-degree rotation. Right now if it's facing up and right, that's going to form a 90-degree angle with the two directions that it's facing. So I'm going to have 90 degrees typed in. Okay, good, it worked out. Now if it didn't work out, if you thought maybe it was 180, okay, we could play with that and we could type in, okay, 180. Nope, that's not going to work. You go back to the drawing board, you try something else. Maybe 45, nope, not going to work. And soon you'll start to realize exactly what the rotation amount is going to be. And then the last step here is we need to do a dilation. All right, so we're going to dilate, and we need to figure out how much. So let's see. Right now, I'm going to see how long it is to get from G to my point on the right, which is technically what point would that be? That would be the pre-image of point E. So to get from here to the pre-image of E, it's going to be 1, 2, 3, 4, 5, 6 boxes. So it's going 6 boxes originally, and the new length to get from G to E would go all the way from -8 to 4 on the x-axis. So this would be 12 boxes. So if you counted it, all these boxes right here, it's going to be 12 boxes. So the new length is 12. The old length was 6. So 12 over 6, because it's new over old, is going to be 2. I want this point to become twice as far as it is right now. So I'm going to type in that my center of dilation is going to be this point G, which is at -8, -3, and the amount that it's going to dilate is 2. And there we go. They fell on top of each other. Okay, so what does that mean for us? That means the two figures are similar. Yes. Okay, we're going to check. Okay, good. We got it right. Okay, now we have another one here. So let's do another one since We have the time. Okay, what do I want to fall on top of each other? Now, all of these are basically like halfway, so I'm going to be working with some decimals here. I don't love that, but we do what we got to do. All right, so I'm going to get them to translate first so that I can map A on top of D. So I'm going from -2 all the way to the right. It looks like it's going to be 5.5. So from -2 to 5.5, I'm moving to the right 7.5 boxes. Okay, and then I'm going up from -2.5 all the way up to 3. So that's going up 5.5 boxes. All right, there we go. They've mapped on top of each other. All right, next thing I need to do, I need to flip this blue one so that the point D is facing downwards. All right, I need to get this bottom line segment that's horizontal to fall on top of the one up here. All right, so I'm going to reflect. Because if I need to flip, that means I need to reflect. Now, it's going to ask me what line I'm flipping over. Now, I want my line to look like this, right? Just the way that my cursor is going. So I need a y equals 3 line. So any 2 points that are on this horizontal line that passes through the y-axis at 3 should work. So I'm going to use 9, 3, and I'm going to use the point 0, 3. As long as the y value is 3, so that I'm showing that it should flip over a line that has a y value of 3. Okay, and now they're facing the same direction. Okay, good. And then the last thing that I need to do, I'm going to have to dilate. So I'm going to use these 2 horizontal line segments to figure out this dilation scale factor. Now my center of dilation is going to be that point D, all right, because I've already matched it up. I don't want it to move. I just want these 2 points, the pre-image of E and F, to move closer to D. So it's going to end up being where the 2 pink points are for E and F. Okay, so where it says dilation about, that's going to be your center of dilation, which is point D. So it's at 5.5, comma 3. 5.5, comma 3. Okay. And I'm just assuming it's 0.5 because I don't think they would give you anything other than that. I wouldn't be able to tell if it's 5.4 or 5.6. Right? It just kind of have to go with the halves here. All right, so 5.5, comma 3 is my center of dilation. And now my scale factor. New over old. The new length for this pink line segment, it's 1, 2, 3, 4, 5 boxes. And the old length is, let's see, I'm not going to count the halves for a second. 1, 2, 3, 4, 5. Here's a half on the right, and another half on the left is a total of 6. So it's a length of 6 for the old, 5 for the new. So the fraction new over old tells me that my scale factor is 5 divided by 6. And there we go. And now it's perfectly mapped on top of each other. So the answer again is yes. This isosceles triangle ABC is similar to DEF. Okay. Alright, and then it's just going to continue just like that. So just make sure you're following that process. I like to translate first, then get them to face the same direction, and then dilate. Okay?